Mathematics, mathematics, learn your figures, learn your shapes, and be careful. For mathematics is so easy and makes life comfortable. And makes life comfortable. Mathematics, learn your figures, learn your shapes, and be careful. For mathematics is so easy and makes life comfortable. All right, now for it. Mathematics. Mathematics, shapes, figures, and what? Carefulness, right? And what? Comfort, right? What are the four things? Learn your fingers, learn your shapes, and what? Be careful. But mathematics is what? Easy and make life what? Comfortable. So why are we here today? We are here to what? To demonstrate to you that mathematics is what? Is easy, and mathematics makes life what? Comfortable. So long as you are what? Careful, right? As long as you are what? So mathematics is about shapes and figures, right? Shapes are what? That's not what mathematics is about, okay? Mathematics is about everyday life. Mathematics is about what? Everyday life. Mathematics is about measurement. Say measurement. You measure, right? Your brain is a super mathematician. That's why you measure. You can just measure with your brain. For example, when you see a gutter, a drainage that you can jump over, are you mean? You will know, right? If you can't jump over it, your brain will tell you don't try it too. Your brain has quickly estimated and measured that what? Are you mean now? Your legs can't jump over what? The length of this what? Or the breadth of this what? Gutter. Is that clear to you? You measure, right? When you are children and your brain share things with you, how do you know that Sumeya's brain is bigger than your own brain? And you now squeeze your face. How do you know? Did you use ruler? No. Your eyes have done some measurement and your brain has interpreted what? The figures, right? Yes. If I give you this chalk and this one, which one is bigger? Who told you? Who told you? That's mathematics, right? That's what? That's mathematics. If I give you 200 and 100, which one will you take? 200. That's mathematics, right? How do you know that your food is about to finish, or is more than half, or less than half, or close to full? Mathematics, right? Right? And it makes life comfortable, right? The closest example I can give to you is your table. Have your parents ever bought things that they cannot move into the house? Maybe you bought one big thing and they are trying to move into the house and the door, is too tight for it. Has it happened? Yes. What happened? What did they buy? Big chair. Good, because the furnitures, they were constructing the chairs. Are you me now? They did not factor into what? Mathematics of what? Of building. Are you me now? Your door, there's an area of door, standard area of door. The height times what? The breadth, right? There's a standard for it, right? Architectural design. We studied modern engineering planning, right? There's a standard measurement for window and standard measurement for what? For doors. Are you me now? If your furnitures, if they are educated, they understand mathematics, they always find out what? The area of what? Standard doors. Are you me now? When they are what? When they are constructing their what? Their chairs. Are you me now? That's mathematics, okay? So tables and household equipment and furniture, when they design it, your refrigerator, before they measure the length and the breadth for manufacturers to design, they always try to what? To take note of what? The standard measurement of what? Of doors. The standard area of what? Of doors. Is that clear? That's mathematics in everyday life. Are you clear? Clap for yourself. Now, I'm aware that most of us have this phobia of mathematics. Are you now? We have this what? Phobia of what? Mathematics. We don't like mathematics. Some of you like it, I know. Some of you don't like it, right? For example, you always wonder, what is X and Y? Is that also? What is X and what? What is X and what? X and Y is nothing. Do you understand me? But what it does in your brain is what? Is what? Is something. Do you understand me? It only gives you a way of thinking and solving complex what? Problems. Do you understand me? Do you understand me? Yes. for example, let me show you how to use X, for example. If I say in your class you are 13, is that also? In your class you are what? And you left with who? With how many? And you left with 5 students. How many students are what? Are remaining. Is that also? How many students are what? For example, this is how X works. See here. In the class are what? 13 students, right? And you left you are one, right? You are one, right? You are one, right? And you left with what? With 5, right? That means you plus what? 5. Sorry, you plus what? 5 has what? Has left the class. That also. How many students are what? Remaining. Okay. So how many students remain now with what? Represented as what? X. X doesn't matter. That's why I said it doesn't mean anything. But what it means in your brain is still the same thing. If I put B, is it not the same thing? If I put P, if I represent the number of students there with P, it's not the same thing. If I like, I can even put pi. You know pi? Yes. Or if I can like, I can even use your nose. You know how your nose is? Whose nose is like this? It's just a sign to represent the number of students that is what? That is remaining in the class. How do you find the number of students that is what? Remaining in the class now. Let that number of students be what? X. Is that also? Now, the total number of students is what? 13. Is that also? Is that also? Now, that means 13 minus the number of students that left. What is the number of students that left? 1 plus 5, right? I have to put it in brackets. So I can get what? 6, right? So 13 minus 6 is equal to what? X. Is that also? So what is X now? X is what? 7. Simple things. So the X doesn't really matter. It's 7 that we are what? We are trying to look for. So we tag the 7 with what? With S. So that what? We can get it right. This one is simple, right? Okay. Now let me show you somewhere else how this idea of X starts from. I know you hate X and Y so much. Is that also? But don't worry. See, mathematics deals with equation. Is that also? Value, equation, right? Value and what? For example, 1. What is the value? This is a figure, right? What is the value of this figure? 1 thing, right? Like this is 1, right? But this is 2, right? Good. These 2 things, right? Is that also? Good. That means now values on their own are represented in what? With figures, right? Values on their own are represented with what? For example, on my right side now, Halima, you are sleeping. On my right side, how many of you are there? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Right? There are 12 of you that are there, right? On my right side. 12. Right? Exactly. On my right side are what? 12 of you. But this is not you. Is it you? It's just representing you, right? It's just representing you, right? This is a type of numerals. This is a type of what? Other people have a way of representing this. You can also represent 12 like this. 1, 2, 3, 4. Right? 1, 2, 3, 4. Right? And then 1, 2, right? This one is called what? Tally number, right? Tally number system. Is that also? Good. Other people also have a way of representing you. This on my right now. Are you me now? So, like the Romans, right? How would they write 12? How would they write 12? X-I-I. What was it? Good. This is how the Romans represent what? You on my right side. This is how the Indians and the what? And the Arabs represent what? You on my right side. Are you me now? This is how our Asian forefathers represent what? You on my right side. With what? Tally what? Tally number. Is that clear? Is that clear? I hope that's clear to you. Another way of representing number is what? Abacus, right? Yes. Abacus, right? How will I represent 12 on abacus? I draw a line, and then again, will I draw that line? Will I draw that line? Good. So what will I do here? Beat. God bless you. Like this, like this. Should I continue? Should I continue? No. Should I continue? No. What should I do next? How many beats here? Are you sure? Should I write 10 beats or 1 beat? 1 beat. You see? That means the one here is the unit, right? This one is what? Tens, right? The next one is what? 100, right? God bless you. This is just figures, okay? But 12 of you, this is a concept. Are you being now? So that's a value, right? Are you seeing how mathematics works? Are you seeing how mathematics works? Now let's look at something more serious. Are you with me now? Let's look at what? How figures relate to each other. Are you with me now? And how value relate to what? Each other. For example, you know now that what? 4 now is equals to what? There are so many ways of representing 4. Are you with me now? For example, 4 is equals to 3 plus what? 1. Is that not so? 4 is equals to what? 2 times what? 2 over what? 1 times what? 1 raised to power of 1 is equal to what? 4. Is it clear? Is it clear? But do you understand why? Good. See, but you understand this one, right? Do you know what confuses you? All numbers are what? Are raised to power of what? 1. That is the way of representing number. Okay? All numbers are multiplied by what? All numbers have a coefficient of what? 1. Is that clear to you, original? So, all numbers are divided by what? Do you understand? Do you understand? 2 divided by 1 is equal to what? Is that correct? No, that's not correct. Is it correct? So what is the answer? God bless you. 2 times 1 is equals to 3. It's not 3. Are you sure? It's equals to 2, right? 2 raised to the power of 1 means what? 2 times what? In 1 places. Are you with now? Just 2 in 1 places. Raised to the power of 2 means what? 2 times what? So mathematics is not what? It's not difficult. Are you with now? Now let's go step by step. Let's go what? This is another way of representing 4, right? I can also represent 4 as what? As what? 59 minus 51. Are you with now? Minus what? Minus 55, right? Good. Minus 55. It will be equal to what? It will be equal to what? Do you get it? Good. So I can do it in many ways. Do you understand? I can also say 4 is equal to what? I can also say 4 is equal to what? Alright, let's see. 1200 over what? Over what? 600 multiplied by what? 10,000 over what? Over what? Over 5,000. Look at it. Don't write anything. Don't write anything. Okay? Do you know it's equals to 4? This is how mathematics is. Don't mind how bogus the numbers are. Are you with now? It's just a value. All these things are the same thing. All these things are what? Do you know why it's equals to 4? How? Do you know how? Who knows? Who doesn't know? I know most of you know. The little ones who doesn't know. If you don't know, raise up your hand. I'll show you. This one, the value of this is equals to 2. Do you know that? The value of this is equals to 2. And 2 times 2 is what? 4. Do you want to know how the value of this is equals to 2? You want to know? See, once you have this like this, this one will cancel this what? This, right? This one will cancel what? This. 12 divided by 6. 2, right? So we have your 2 here. So 6 here is 1, 6 here is what? 2. This 3 0 will cancel what? 3 0, right? It remains 10, right? 5 divided by 5 is what? 1. 5 divided by 5 is what? 10 divided by 5 is what? So we have 2 left, right? 2 times 2 is equals to what? Is it clear to you? Is it clear to you? Now, let me show you how x will come here. Let me show you how what? X comes into it. Now you know, right? You know how this works, right? Now, if they remove one thing from here and put x there, they say you should find x. That is just the mathematics involving x. It's not as if x is something else. Are you in now? Should we remove one thing and put x there? Yes. Which one should we start from? This or this? Let's start from the simple. Okay, so if I put like 4 is now equals to something plus 1. 4 is equals to what? Something plus 1. Find out something. What will you do? Let that something be what? X. Is that clear? Let that something be what? X. Khadija? Usama? Aisha? Do you understand? Do you understand? Good. Let that something be X. Now, what will you do? get to 4 minus 1? You are thinking. Are you me now? If you get to a level you cannot think, you have to solve. Okay? Let us solve it, right? Now, we talk about steps. What do you do now? What is the on? This is a formula, right? It's a formula, right? Good. You what becomes a formula or an equation is what? A mathematical relationship. Are you me now? Showing the relationship between two what? Two figures, two values. Are you me now? On both sides of what? The equality. This is the equality sign. So this is an equation. Are you me? What is here must be equal to what? What is here? That is the law, right? It must be balanced, right? So now, when you have something here you don't know, it is called the what? Unknown, right? It's called the what? Unknown. It's called the what? Unknown. So now, when you have unknown here, what do you do next? What's the next step to do? Look up. You what? You collect like terms, right? What is the like term now? You take the figure. Are you mean now? This one here. Are you mean? You take it here, right? So if this man here flies from this place to this place, when he crosses the river, what will happen? It will become what? 4 minus 1 equals to what? X, right? So 4 minus 1 is what? 3. So x equals to what? 3. Is that also? Now let's put 3 back into where we put x before. Let us see if it is true. 4 is equal to 3 plus what? 1. Do you see it? If you remove any of this figure and put x there, you will still get what? You will still get 4. Are you with me now? So 4 is equal to what? 4 is equal to x over what? 600 multiplied by what? 10,000 over what? Over 5,000. If you solve for x now, are you with me now? X will be equal to what? 2. X will be equal to what? No, x will be equal to 2. If you solve x, what will be the value of x? The value of x must be something over 6,000 multiplied by what? 10,000 over what? 500. You want us to do it? You want us to do it? Yes. You want to solve it? Or you want to ask a question? Ask a question. You don't understand what the impact of red light is, right? She said she doesn't understand what the impact of red light is. How many of you don't understand what the impact of red light is? Many of you don't understand what the impact of red light is. Yes. Because you are not all on the same level in mathematics. You are not all on the same level in what? Mathematics. Now, watch before we come here. Now, all of you listen. Listen. You know your like terms? 4 is like 3 and it's like 2. Is that also? Yeah, because they are figure, right? A is like B and it's like X and it's like Y because they are alphabet, right? Are you me now? That's your like terms, okay? That's not what? Are you still confused? So what I'm saying is this. You see, here, are you me now? If we solve X now, we'll get what? We'll get 1 as what? 200. Are you me now? If we solve X, we'll get what? 1 as 200. Is that clear? Good. Should we go ahead and solve it? I don't want the younger ones to be confused. Will you be confused if I go ahead and solve it? Will you be confused? You will not be confused. Are you sure? Okay, now, let's make it easy. Let's make it what? So what's the first thing to do? When you have something over something multiplied by something over something, it's very easy, right? You multiply the numerator by what? By the numerator. And the denominator by what? Is that clear? Is that clear? So you now have 4 is equal to what? X times what? 10,000. Over what? 600 times what? 5,000. You understand me? You don't have to stress your head computing. You cancel out what? 0 to reduce it, right? 1 0 will cancel what? This one will cancel what? This one will cancel what? This one will cancel what? Do you see it? So what do I have left? 4 is equal to what? X times what? Times 1. Over what? 6 times what? 5. X times 1. 4 is equal to what? X times 1 is what? X times 1 is what? 1x is simply the same thing as writing what? X. Do you know? Do you know that? You don't know. 1x is the same thing as what? As x. Because 2 is the same thing as 1 times what? 2. Do you know that? Do you know that? Hanifa, do you understand? See, 3 is the same thing as what? 1 times what? 3. Because every number has a coefficient of what? 1. Is that clear? Is that clear? Good. See? Now, so this is x. 1x is what? X. Do you know what that means? Yes. 1 Hanifa is what? Hanifa. 1 Hanifa is what? Hanifa. Is it clear? So x over what? 60 times 5 is what? 60 times 5 is what? 300, right? 300, right? So what do? When you have something like this, listen to me. Whenever you have something like this, 4 equals to what? X over what? 300. Is that correct? Automatically, this one is over 1, right? Do you know? Yes. Do you know that? Yes. So what do? You cross multiply, right? Yes. When you cross multiply, x times 1 is still the same thing as what? X. X now is equals to what? Then you cross multiply. So let me shift this one up so I don't get confused. See, it's 4 over what? 1. Do you know that? Do you know that? Yes. 4 times 300 is what? 300 times 4. 300 times 2. 600, right? Times 3. 900. Times what? 1,000 what? 1,000 what? X is equal to 1,200. Remember I said when we solve, we'll get 1,000 what? 200. Is that also? If you that about 1,200 that we delete the other time, we have come back to what? To it again. Is that clear? Do you understand? Yes. So when you see they talk about things like x and y, are you with me now? It's just a way of showing, letting you understand how to what? How to find a missing value. How to find the what? Is that clear? Is that clear? Clap for yourself. Now, we move on to the next session. The next session will be more interesting than what? Than this. Next session will be more interesting than what? Will be more interesting than what?